I'm Joyce Hornady. You might say accuracy is my business. I make bullets.
You are listening to the Hornady Podcast.
Thanks for joining us and enjoy the show.
Hello, everybody. Thanks for tuning in on the Hornady Podcast. I'm your host, Seth Swerzik. Again, thanks for tuning in on this one. We appreciate you listening. If you're not, please subscribe. We put out a bunch of good information, a bunch of good conversation. We think you'll enjoy it. And on this episode, I really think you'll enjoy it. I've got two Hornady employees, longtime employees that got a great history with the company and are also critical parts of our number one product, which is bullets. So please join me in welcoming on the show, John Potratz, Mike Timmerman. Guys, thanks for coming on the show.
Thanks for having us.
Yeah, really excited about this one. You know, we were talking before we started recording that in these podcasts, you know, now we're well over a year into this, the topics that trend really well for us, that people really like to learn about, are deep dives about technical things, cartridges, bullets, ballistics, that kind of stuff. Well, we've highlighted certain bullets. You know, the CX bullet, for example, is one of our more popular episodes. And we talk a little bit about its design and how it's manufactured and how it's used. But the reason I got you guys on the show is I want to take a dive for our listener into how a bullet is manufactured, because there's a lot to it. I remember when I first started here 10 years ago tomorrow is a decade. I remember being on the floor, Johnny showing me how a bullet's made. It was like drinking water from a fire hose. I mean, I'd spent my whole life shooting bullets, and it was like, are you kidding me? This is how complex it is. And then when you kind of scale back and you kind of get understanding of what's going on, it's not quite as complex as maybe I thought it was. Because essentially you just take hard metal and hit soft metal and it takes the shape, but there's way more to it than that. So I want to go into how that's done and what makes Hornady different and what makes Hornady bullets better and how we're able to make such good quality bullets at such large scale, because I don't think there's a single bullet manufacturer out there that can hang with our volume. I mean, we simply make bullets.
Yeah.
So before we get into that, I think we need to give our listener a little bit more of background on who you guys are, because you're not just guys out there running a press that just started. You guys have been here for a while. No offense, not making any old jokes, but you guys have been around. You know how to make bullets, and you know a lot about the company. And so I'd like to hear kind of individually where you guys started. So I don't care who goes first. John, let's hear from you. When did you start? What got you at Hornady? And what's your career looked like over the years?
Well, you know, I started out in manufacturing at that time it was Sperry, New Holland, but it's Case, New Holland now.
Okay, making combines.
But, you know, making sheet metal parts and then machining castings. And then, you know, worked there for 4 years, and the Carter-Reagan years came in there in 1982, got laid off from there. And then it took me till, well, about a year later to get in at Hornady. But, you know, that's a local manufacturer. Small company versus big company.
Yeah.
That Case was, or Sperry was.
Hornady was way smaller in
19.
Yeah.
We had, you know, maybe 100 employees in all four divisions.
Oh, wow.
Small footprint, you know, where the plant is now on Old Potash.
Mm-hmm.
You know, pretty small place. You know, each division didn't really have a lot of employees. I think I was, in the bullet division, I think I was like employee number 53. You used to have a time card rack hanging on the wall where you walked in, and I think I was 53.
Okay.
And then, I mean, you really became something if you made it in. There was 3 time card racks. If you made it to the first rack, okay, you were a long timer there then. And then I think I did make it to the bottom of the
good for you
first rack before that, you know, we went with a different timekeeping system. And
you made it. So you started making bullets then, or would you get into a different
I started as a press operator, 1983.
Okay. All right.
And May 9th, 1983. So if you do the math, here in about 2 months, well, May 2023, it'll be 40 years for me.
Good for you.
And I've been out on the floor there that whole time, basically in different roles. Started out as a press operator and then moved up to cell leader, and then started putting new products on new presses, getting them up and running, working with the engineers on that and getting the new products running and turning them into, okay, that's a regular production deal now instead of an R&D project. And
that's cool. That part is probably where I came in, 10 years ago. I remember anytime that there was a new bullet, there was a team of guys that would kind of get that bullet up and running and
Yeah.
then turn it over to regular production. And, I think back on some of the big projects, obviously the A-tip bullet,
Yeah.
which is one of our, grand slam home run products, just an amazing, amazing product. I know you had a hand in that one. If you would, tell us a little bit about your competition world, because you got into the competitive shooting.
Yeah, back in, I think 2007 was, I think that was about the first summer that Joe and Christina Thielen, they were doing 1,000-yard bench press shooting.
Mm-hmm.
And then they'd go to Pella, Iowa, and maybe go to Colorado. And there was one down in Yukon, Missouri. And they were doing 1,000-yard bench press. And, they were a young married couple, and they're going to start a family. And, okay, we got to hand this off
Yep.
a little bit so they can concentrate on that. And so he got us started in that. A bunch of us went down there to some of the matches, gave it a try, and
Got hooked.
it was kind of fun.
Yeah.
Okay, we're taking something that we made. We got a hand in the accuracy of these bullets here, and okay, we actually got to basically field test them, see how they performed.
In a competitive world and in
Yeah,
a hyper-competitive environment, because bench rest is
yeah,
cutthroat. I mean,
Mhm.
one bullet out can really separate the herd.
yeah.
40 years.
Yeah.
That's amazing.
The bench press stuff's been pretty good to me. I've managed to achieve gold level in IBS.
Wow.
So there's, I don't know, I'm going to say 20 to 25 people that are gold level, and there's 3 that I believe that are platinum. And it's just based on how many points you scored over your
Career.
career.
And you're still
bench press
competing.
shooting. Yes.
Awesome. What cartridges are you competing with, or what bullet
Well,
diameters?
I'm using a 280 HK, which is a 280 Hummel and Kiff. It's
Mhm.
basically a 280 Remington case with the shoulder blowing out from 17.5 degrees to 30 degrees.
Okay.
So for a little more case capacity, I'm using that for light gun, and then for heavy gun, I'm using started out with a 30 Boo Boo, and then switched over to being self. Those cases were pretty difficult to come by.
Yep.
That 15, 20 years ago, and then we switched to the 300 PRC, and that cartridge is working really well.
Yeah, you guys I know have won a bunch of matches with that one.
Yeah.
And for the listener out there, if you want, go back and listen to the 300 PRC podcast. I don't know the number, but Joe Thielen talks about, going from the 30 Boo Boo and the 8x68 cases, and then he was working in the case plant at that time doing some engineering, and came out with at the time it had no name and no head stamp.
Yeah.
But what turned out to be the 300 PRC, just for you guys to shoot bench press with.
Yeah.
That's pretty amazing.
Yeah, and it's performing well.
That's what
I can't
we like
stress
to hear.
that enough. On a heavy gun, platform, if you've got a heavy enough gun, the recoil's nothing really.
Yeah.
If it's pushing back a 60-pound gun, which is about what mine weighs, it only slides back, inch and a
Beautiful.
half. So
That's cool.
Gun tracks really well, and the cartridge is just really forgiving.
Yeah.
We take our time to weigh sort cases and weigh powder charges and weigh sort the bullets and stuff like that. But it's just, even if you didn't do that, I think you'd still do
Really?
pretty well.
That's cool. I got to ask, John, were you a gun guy or a hunter before starting to make bullets? Or did you get captured by it as you got?
I went bird hunting,
Uh-huh.
back before I started at Hornady. But,
Yep.
but no, I wasn't really a, big center fire guy. No.
Okay. Well, now you
Shotgunner.
are. Yeah.
Now I am.
Yeah. Good stuff. John, well, thanks for your 40 years here. Coming over to you, Mike, what's your career look like? I know we just heard from John, and
Mhm.
I'm guessing a lot of your work involvement will be kind of parallel to each other.
Yeah, we've worked together for a long time. I can remember I, too, worked at New Holland, got laid off there,
Yeah.
and came out to Hornady for an interview. And my anniversary is this month, and the 12th of this month, I'll have 39 years.
Wow.
And I'll never forget it. Dale Franzen was the plant manager then, and I was just a stupid young kid. I'd been out of the Air Force for about 3 years, and he brought me out to the shop and showed me a bullet press running, and he thumped me. He said, "Think you can do that, boy?" And I said, "Sure."
Yeah, yes, sir.
And of course, I'm thinking, hell no, I can't do that.
Yeah.
But turns out I actually could. And in those days, we didn't have a lot of training.
Right.
You
Lot
know,
of
you
on the
basically
job.
shadowed somebody for a little while, and then these are yours, and you had 2 headers, 2 presses, and 2 trimmers, and go at it. And
Wow.
we were pretty lucky. We got a guy that works for us who's been there a long time, man, almost 50 years now, Whitey.
Oh,
And
he's been on the podcast. People should know the voice and the name, Mike Jensen.
tell you
Whitey.
what.
Yeah.
he's that's just my opinion, probably the greatest bullet maker in America, maybe in the world.
All time.
Yeah, that dude can do anything.
You know
Yeah.
what? You say that. That's probably not far off the mark.
No, when we don't know what to do, that's who we go to.
Yeah.
He's
Even today. But back in the day when John and I started, we worked next to each other. He ran 1 and 2, and I ran 3 and 4. And we had a lot of times together. I remember when he got married, because he had taken in his trimmer bench, he had carved a little heart with Johnny Loves Debbie in it. And so we
I don't have my ring on, but we're still married.
Yeah,
we're-
good.
So we've got a lot of history together, and John's pretty humble about his ability. Right now, John is really like my point guard. I'm the plant manager now.
Okay.
I started there as a press operator. I did that for about 10 years, and then I became the plant supervisor, and then the plant manager got let go, so then I became the plant manager. I did that for about 15, 16 years. And then we didn't have a training program, and I'd kind of burned out being in management, so they let me go start the training program, which was fantastic.
Mm-hmm.
I got to still meet all the guys and pass along, really wrote down a lot of the tribal knowledge that we had so that we formalized it so that we can train our new guys, because we went from when we started, there was 22 presses and 11 operators,
Yeah.
and now we got over 200 operators.
Wow.
So,
And you got to see the level of training that you did or didn't receive when you started, and to start the training program that's become critical to hiring new employees.
right. Early on, some of the guys didn't want to share anything with you because they were afraid you'd know as much as they did. And, so when the training program started, really, I would write all this stuff down, and then John would read it and Whitey would read it. And if we all agreed that that's how it was, that was the best practice, then that's how we did it.
Wow.
But
From the ground up.
yeah, that was exciting. And then, about 3 years ago, they asked me to come back and run the shop again.
So you're bullet plant manager and making the best bullets we've ever made. The demand is infinite. And I don't say that facetiously just to prop up our product. I truly believe, working in the engineering field that I did and doing ballistics and doing a bunch of shooting between here and there in the last decade, I really think that we make better bullets today than we did even just a few years ago with process controls.
Oh, yeah.
And, just different ways to work the material. I really think we're making the most accurate bullet we've ever made.
Yeah. When John and I started out, we didn't necessarily have formal setup sheets for bullets. So, you're talking about a 14-station press. You'd have to kind of wander around and find all the parts. We didn't have a tool crib,
Yeah, basically all the parts for all the setups on all the presses. Of course, there's only 22 presses, basically in one cabinet. One cabinet that's 3 foot wide, 6 foot tall, and 25 drawers in it.
But everybody rat-holed stuff, and so that was kind of how that worked.
Some of the bigger stuff, that wouldn't fit in the cabinets, but swedge dies, draw dies, bowtail punches.
And basically, we bought old Waterbury presses, used ones,
Mm-hmm.
and did what would you call a Craigslist rebuild? We repainted them.
Yeah.
And then we brought them out on the floor and we ran the hell out of them.
Yep. And I think that's another important note. I'm glad you brought that up, Mike, that some people think, or don't understand actually what a bullet's made on. And we use, there's others out there now, but the Waterbury Ferrule transfer press, that's that's what made the company.
Yeah, that's where we started.
Yes.
And those things go back into the 1800s.
Mm-hmm.
And a lot of the ones we're using are World War I, World War II era.
Oh, yeah.
And they basically are just big machines that go up and down. And the punches and the dies that you put into them, that's what makes bullets. But Waterbury Ferrule transfer presses are used to make other stuff around the world.
Yeah, it's a 30-ton press, but the transfer just takes one position and moves it to the next. So you have a 14-station die set, and it works through that whole process of drawing the cup. And then you put your interlock in, and on your header you would be cutting a core of lead, and then you'd insert the core of lead, and you'd core seat it, and then you would pre-swedge it, shear it if you're making a standard rifle bullet, and then you would final swedge it, and then point finish it, size it, take out all the taper, and control the diameter. That was the process. Back in those days, you had a trimmer. So you had your draw sight on the right-hand side, and the cannler on the old military-style turret was on the right-hand side. They dropped out. You picked those up. You put them into your trimmer, and then you would sort through the jackets, put them back up in the hopper on the other side, on the left-hand side of the press, so that we could swedge them up.
Oh, wow. Those times have changed a little bit as far as...
You handled the weight about 7 times.
Right.
Oh, boy.
Right.
Yeah, we're a lot more efficient than that now.
Yeah, we are.
Yeah, and that's also why we make so many bullets, is we are very efficient. And we'll get into the details on the technical side of how a bullet's drawn out and made. But, Mike, you've obviously had a long career working side by side with some of the greats here. Obviously, Johnny P, as we call him, and Whitey. And Whitey's still here, and he's still the go-to guy.
He is.
He is simply, he's got to be, honestly, one of the more patient men I think I've ever met. As far as like teaching people stuff, he's very, very patient.
He is.
And
we benefited a great deal because of his ability to explain to us when we were young what was happening in the process, so that we understood cause and effect, because that's what's important. When I do this, what does it do?
Oh, sure. You have to know that to connect the dots.
Yep.
Yeah, and he was one of the most experienced guys there when we started there, because he'd been there. He's only 2 years older than I am, but he had been there 7 years when I started there. So, I mean, he was, very experienced operator by the time we started there. So, he was a pretty good resource for us. If we were having a problem with something, he could come help us out. And, he's always been a good sounding board and source of knowledge. And, if we were going off on the wrong direction on a problem, trying to fix it, we'd go talk to him and, I think, but your problem's probably really over here, and he'd sort you out and steer you in the right direction. And he's always been a good resource for us.
What's really amazing to me, and this is tangential to, making bullets, but Whitey chambers your match barrels.
Yes.
So he does chamber work building guns. He can make probably one of the best bullet makers ever. He can build anything out of metal. He can build anything out of wood. And he'll help you pour concrete on the weekends. I've poured several slabs of concrete, or helped pour slabs of concrete for various people, and Whitey shows up, and he's got all the tools, and he's a very gifted craftsman, and I think a craftsman's the right word for him, because he can make anything out of anything.
He can do anything.
Mike, I want to ask you as well. So before you got into making bullets, were you an outdoorsman, or were you a shooter, and did that change as you got into the company?
As a kid growing up, my stepdad and I, we always hand loaded. In fact, when I got my job at Hornady, my old man thought that was just the best thing ever.
Mine too.
Because, it meant free bullets to him, But I remember being a kid hand loading. We deer hunted.
Okay.
I'm the second youngest of 8 kids. So my old man would get 10 deer permits, and we ate a lot of deer meat. But my uncle had a ranch up at Taylor.
Okay.
And that's where we always hunted.
Gosh, I like that area.
Yeah, it's beautiful.
Yeah, for those listening, don't go to Taylor, Nebraska. There's nothing out there for you. It's just leave it for us.
Exactly. They live clear out on the West End Road, which would be the end of Loop County, the beginning of Blaine County.
Okay. But
we always hunted there. And
endless sandhills.
And just slaughtered deer.
Yeah, mule deer, probably whitetail out there too.
My old man if he had a permit, it had to be filled. That was his attitude.
Well, with eight kids, you probably needed it.
Yeah.
Awesome. Did you get into any of the competitive stuff like Johnny?
Not really. Whitey and I there for a while. We did bowling pin shoots.
Oh yeah,
and we got pretty heavy into that. That was pretty cool. I do want to say about the match end of it. It's kind of cool how that all evolved, because we made match bullets, but it really wasn't a big focus of what we did. And I think it was around there, 2007, 2008, we decided that we were going to start going to some of these 1,000-yard matches and just see what was going on. And at that time, you have to realize, Whitey had been making bullets for 30 years, and I'd been around for 20 years, and we kind of set that aside, because you wanted to find out what's important to these guys.
Yeah.
Right.
Whether it's real or not.
Yeah. What's important?
Whether it's real or imagined, if they think that's important, maybe that's something we should focus on.
Right.
But to be honest with you, all the things that they thought were important were absolutely right.
Yeah.
Yeah.
And we started to really make a focus of making match bullets. And I can't, if you'd asked me 20 years ago, we were going to make as many match bullets as we do every day, it's crazy.
Oh, yeah.
We're a match bullet company.
Yeah. I mean, in 2015, that was the line of demarcation when the ELD match bullet and the ELDX bullet, which is made very similar to our ELD match bullet and held to very similar accuracy standards.
Yeah.
I feel like for me, that was the line in the sand where after that, our match bullet production and our match bullet use in sports greatly increased.
Oh, yeah. But we were there to learn, not to teach.
Yeah.
So I think that was the right attitude to take.
Sure.
And to be honest with you, our guys that go to the 1,000-yard matches, they're very well liked.
Mm-hmm.
They're a part of that crowd, and they've made a lot of friends with people.
Yep.
So,
Yeah, and Joe and Christina were pretty good ambassadors for the company.
Yep.
absolutely.
And, I mean, they learned a ton from the people that were already in it that were, doing a good job and winning. And then they started
Winning. Yeah.
They started winning, and then they kind of handed that off to some of us. And
the rest is history.
the rest of history, they got to start their family. And
Yeah, and we got a pretty good bench rest team since then. I mean, we've got a team that are
Good bunch of guys.
Yeah, good guys. Well, and they're just good guys all the way around. But then you get them to the matches, and they're interacting with the people well. They're flying the Hornady flag, and they're competitive.
Yeah,
and that's cool.
Yes, they are.
Now, Hornady offers Sub-X component bullets from .308 up to .458. The Sub-X features a lead core and is designed to provide deep penetration and high weight retention at reduced velocities. The patented flex tip combined with long grooves in the gilding metal jacket ensure excellent expansion at velocities down to 900 feet per second, delivering big results without the big bang. Sub-X bullets from Hornady.
Well, guys, I'm going to take this time now to transition into the production of the bullets, right? So you guys obviously have a vast amount of knowledge, and it would be too technical, I think, to really get into a lot of the aspects. But largely, let's talk about the raw material, how that comes to us, what we do with it, and then the draw process and why that's significant for us. And what are some of the intricacies that we face in manufacturing a bullet? What are some of the things that are difficult to make, or how do you guys really extract the most accuracy out of a bullet? Because yes, we talked about match bullets, and they are accurate. And the A-tip bullet, which is the most uniform, consistent bullet ever manufactured in the history of ever, but our 30 cal 150 grain spire point. I have shot bullets in the lab when I would help downstairs to shoot for accuracy. A classic 150 spire from a 308 would just pound a single knot hole.
Yep.
So we make accurate bullets across the spectrum. So let's kind of start at the beginning. We talked about the press. Let's talk about some raw material and then kind of what that looks like going through.
Why don't I talk about the just getting the strip in and making the cups, and then I'll kind of hand that off.
yeah,
to
there you go.
We get our strip in, and then we run it through a double acting press, which is a blanking press. It actually blanks out a disc. There's a second ram that comes down, and it shoves that punch through a draw die and makes that into a drawn cup.
Okay, so it starts life as something maybe 8 inches wide and rather thin.
Yep.
Just brass
035,
or copper.
028. We use as thick as 050 and 060.
Wow. Okay, so it punches it out into a circle, and then that circle of material is punched into a die and forms a cup.
And it's made into a drawn cup.
So how precise is that process? Because when you hear about, okay, you punch out a disc and then you punch that disc into a die, it doesn't sound precise.
Well, we can't make a good bullet with a bad cup.
Okay.
Right.
We have to make really good cups. And I think in the last 5 years, we've even stressed even more because of the match business. We've stressed even more uniformity, that they're not just concentric, which means that true concentricity is material thickness variation,
Oh, it's not just perfectly circular. It's the variation of the thickness in that circle.
That's right.
Okay.
But our concentricity gauge actually measures both at the same time, doesn't it?
Mm-hmm.
So it takes both factors into consideration at one time.
Okay, and concentricity, I mean, it's got to be less than a half a thou or a thou. What are we looking for?
Now we're looking for 2 or 3/10.
Whoa. So half of a thou.
Yeah, if we're going to make good cups and make really good match bullets, we got to have cups that are
Nearly perfect.
2 or 3/10 at the most.
Wow.
And
So-
there's multiple cups being made with each stroke of the press. So as far as diameter of the cup, we want that to be, about the same tolerance on it.
Yep.
If you're making 6 cups at a time, you want the diameters to be within a couple tenths of each other. If they're a thousandths and 2/10, that's too much.
Too much.
Just
Wow.
because of the process
Yep.
we're using, downstream from it, that would show up. That would show up on your finished
Just
product.
with bad accuracy, large dispersion. And that's pretty remarkable when you think, it kind of falls in line with pretty much everything else in life, is the preparation is often more important than the actual job, whether you're tiling a wall, painting a car, or making a bullet. The stuff you do beforehand, getting prepared, get everything right, makes the difference in the finished product. And in this case, those cups are hypercritical to making a good bullet.
Yes, they are.
And that material that is not punched out into a disc, that's all recycled.
That's right.
So
That
it
all
just
gets
comes back to us.
chopped up. We send it back to our supplier, and then they remake it back into strip.
That's, because we make a lot of bullets. We need all the material we can get.
We do.
All right. So now that you've got the cup and you've got a certain diameter and a certain thickness, what other raw material do we need, and how does that look going through the draw process?
Well, the lead process, we get it in bulk. We get it in 1,000-pound blocks, and then we melt it down into our lead pot. We pour that into a water-cooled mold, and then we take those out to our extruder, and we extrude those into lead wire.
Okay.
And that lead wire is then going to become the core for the bullet. And again, we make everything from 130 diameter to 400 diameter, depending on what you're making for a bullet.
Yep.
So, 130 is for 17s, 400 is for a 50 cal. So, there's everything in between.
A lot of different variation.
And it's all determined by caliber, what size lead wire you're going to need.
Okay.
Generally, a 7mm takes 195. A 30 caliber, it takes 300 lead.
Okay. So you got these rows and rows, and for those that have been on a factory tour have seen these rows and rows of lead spools organized by diameter.
Yep.
And so you've got lead, you've got the copper jacket, and now we got to put them together. And that process, somewhat proprietary, but there's a lot of stuff that's not secret in this world. But like you said, it's a 14 draw process. Is that pretty consistent for every bullet?
Plus or minus a couple, depending on what product line. If it's got a tip in it versus being a hollow point.
Okay.
A hollow point would have a couple fewer stations, but okay, we got moldable tips too.
Oh yeah.
Oh, we've got tons of tips.
Yeah, we got tons of tips. We got
different sizes, lengths,
hard
diameters.
plastic tips. We got rubber tips. We got aluminum tips.
Yeah,
Yeah.
we've got it all.
Lever evolution.
Oh
We
yeah.
got flat tips, kind of blunt, rounded tips. We got pointy tips.
Yeah. We got all kinds of stuff.
So you've got this Waterbury ferrule transfer press, and when I look at it, you put your raw material, your cups in on the left, and then it starts the draw process from left to the right. As
Correct.
the press will go down, the punch will hit the material into a die. As the press comes up, the bottom track will transfer one station over to the right. A new cup comes in, and it just keeps marching it down the line.
Right.
So what are those different draw processes, and which ones are very, very critical, and how do we form things like boat tails, for example?
Well, the draw process is pretty critical because you have to move copper slowly. It'll tear or it'll start to gall. If you're working it too hard, it'll gall the dies up, or it'll start to bite off pieces. So the percentage of reduction has to be just spot on, basically, for everything. And when you go into a match bullet, which John could talk a little bit more about, it's even more critical. Mostly those are skinny jackets, but they're super long bullets. So you're not just doing diameter reduction. You're really doing some.
You're doing jacket wall thickness.
Yeah.
And that jacket wall thickness, if it starts in the cup, it being critical, it's critical in that world as well, because you're taking a cup that's short and fat and you're trying to draw it to thinner and longer. So, what's that draw process look like? You can't do it all at once, right?
No, you don't do it all at once. I mean, you do like a measured diameter reduction, either through 4 draws or 5 draws.
Okay.
And, if you're starting out with the 600,000th diameter cup, first one might be just say 450, and then down to maybe 400 or 380, and then you just kind of go down the line depending on what caliber you're making, and
getting smaller and smaller in diameter, longer and longer in length, and keeping
normally,
that uniformity.
Like on a match bullet, it could be 4 draws, it could be 5. It depends. It depends on, like how long the bullet is and things like that. But okay, just say if it's 4 draws and you got 4 draws, you only draw the 4th draw through, about the length of what your pinch trim jacket would be.
Okay, what's a pinch trim jacket? So you draw the bullet out, it gets longer and longer and longer.
And then you say like the 4 draw setup,
mm-hmm.
the 4th draw, you're not drawing all the way through. You're not drawing the full length of the jacket down to bullet diameter. You leave the 3rd draw diameter up at the top, so the pinch trim punch could get down inside of that.
Okay.
And then you're actually pinching it off to the length of jacket you want to make that specific bullet.
Oh, so it makes the length of the jacket now uniform.
Yeah, so, you go through these draw positions where you got the diameters controlled down to 1/10 of a thousandth. And then, with your pinch trim position, you're controlling the length of that jacket that you're going to make the bullet out of down to 1/1000th of an inch.
Okay.
Then once you got a pinch trim jacket,
Next process, you got a big hollow tube that's very uniform.
You got a hollow tube that's uniform jacket thickness, uniform diameter, uniform length. It's going to weigh the same with, if you want to get super technical, with the exception of what the thickness is in the bottom, which you didn't do anything with the bottom of it other than push on it.
Yep.
But, the weight's all going to be static, length static, diameter static, concentricity static.
So making some of the best bullet jackets in the world just by hard metal and soft metal, just push them together.
So now that you got jackets is just exactly what you want. Okay, we were inserting a core lead that, is made on a different machine.
Okay.
And then the core lead's a specific diameter, specific length, specific weight.
Yeah,
to get you the weight you want
critical
for that bullet. Yeah, the weight's critical. And, and we have, during the stroke, we have sensors on the press, with the cup as well as the lead. That'll tell you if the cup's too thick or if it's too thin, it'll shut the press off and alert you to what position it was, why it shut off.
Wow.
And then the same thing with the lead.
Mm-hmm.
Assuming the lead is what you wanted, and it passed a sensor, now you go over to core seat it. And you might have 1 core seat, you might have 2.
Oh, because the lead's loose in the cup.
Lead's loose inside the cup.
So you have to seat it, hit it with hard metal.
Yeah, and you got to let it free fall down to the bottom so you can accurately measure that core.
Mm-hmm.
Okay.
Accurately measure it, make sure it's right. It's the weight that you want. Then we'll move over to the core seat. Then you core seat it. Let's say if you got a flat base bullet, you probably might only have 1 core seat, but you're just basically swedging that core down to that jacket, filling it out so it's touching all the way around. It's getting smashed in there, and you might have just a little tiny bit of lead bleed up around the punch, but you're just seating that into that jacket, so it's just this one solid mass now. But then you got to open the rest of the open tube at the top.
Yeah, well, and people, you go, hey, we're going through the process, and you hear that, okay, yep, they crushed the lead in there. I think few people understand how critical that is, because if that lead is not uniform all the way around the ID of the cup, your bullet has horrible center of gravity offset, and it's going to spin around like an out of balance tire. And when you go to shoot it, if you shot 5 of those, you'd have a shotgun pattern.
Yeah.
So just something as simple as smashing lead into the cup is again such a critical point for accuracy.
Mm-hmm.
And the other thing you have to compensate for, as the press runs, the punches start to wear. You have to accommodate the wear with your core seat punch, because the inside diameter of the jacket continues to get smaller and smaller. You can't use the same, everything's made to be sized to fit. So like bow-tail punches are made bigger than the die so that you can polish them down to fit the die you're currently running. Because every tool has a life. So that's how every draw die has a range that we allow them to grow. once they've gone beyond that, then we grind them up to the next size. 6 millimeter swedge dies. Once they're too big to run anymore, then we're gonna make those into 6.5s, and or 25 calibers, or we're gonna make 30 calibers into 338s.
Yeah. I did not know that. That's interesting.
We just burn them up to the next the next caliber.
That is remarkable. And yeah, we have EDMs for burning carbide, and that's a neat recycling part that I was not aware of.
Mm-hmm.
So, all right, John, you got the lead cord uniformly smashed into a super uniform jacket that's drawn up. Now, on, let's say, boat tail bullets, for example, how does that boat tail get on there? When does that process take place? And then when does the ogive start to take shape?
Well, you're doing the boat tail in the core seat position. I mean, flat base, a lot of times we just hit it once because, you're just doing one thing. You're just seating the lead down in there. But when you're forming that boat tail, we might hit it twice.
Okay.
Sometimes we do, sometimes we don't. It depends on what bullet is.
How long the boat tail is, probably how much material's down
and
there.
we have some longer boat tails now, and so longer boat tails more than likely are going to be hit twice. And then, the first one's going to take it half to 3/4 of the way, and then we'll finish it off in the second core seat.
Okay.
In the second core seat, we're controlling that with ejector position inside the die.
Okay.
And
kick it out of there.
And then how hard we're hitting it. And, some bullets have personality. Some bullets like to be hit really hard. They shoot better that way. And some bullets not so much.
Interesting.
It just depends. You got to learn the idiosyncrasies of that particular bullet, what it likes.
Wow. And that's the tribal knowledge that you talked about.
Yeah,
Mike,
and I got a book in my toolbox that I started, back in the 90s. I got stuff entered in. I put dates on stuff.
Yeah.
Back in the 90s on the first VMAX bullets we did in the early 90s, what it liked.
Yeah.
What can you get away with on concentricity on the jacket? What you want it for boat tail length? Does it like being hit hard? Does it like being hit soft in the core seat? I just got a book. I had a guy here this last week goes, I bet that book's going to come up on auction, isn't it? It's going to go the highest bidder when you leave.
If Johnny ever retires, we're going to auction it off.
I want his calculator because he has a calculator from 1979 that's still, it's as long as I've known it, it's always had a wire around it.
Well, it's got a zip tie now.
That's it.
That was back from my New Holland days.
Yep. Still running.
It's still running.
Is it a Casio or Texas Instruments?
It's a Sharp. It's a Sharp and it's a LCD.
There's no more numbers on the letters.
It runs on a 9-volt battery, and the case of it's like a front and back. And it's when I worked out at New Holland in machine shop, you had all this coolant mist coming out of these machines I was running. That coolant mist was actually kind of hard on plastic. Yeah. Anyway, it kind of rotted that plastic away. Hence a piece of wire I used to have, and now a zip tie on it holding it together.
Oh, my goodness.
But I had to take it home because people would use it.
Yeah.
They'd go over to my toolbox, grab it out of there, and use it, and then they forget to shut it off because it actually has a switch you got to turn it on with and turn it off with.
Does it make like a sound like
no
when it
sound.
Powers up?
No sound.
That'd be cool.
Anyway.
All right. So we've got a bullet now, jacket's drawn out, the lead core seated. You form that boat tail as you're doing the core seat, and then now we have an empty tube up top. How do we form that ogive?
Okay, the fingers we have in the track, the track's moving left and right.
Mm-hmm.
It actually has some ramps, and the ramps are actually, the way the fingers are designed, actually roll that over. So like open ends up, goes through the core seat, comes up into the rollover fingers, open end up, and then hits the first ramp, turns it 90 degrees. Hits the second ramp, turns it the other 90 degrees. Now that's inverted. The open part of the jacket's down on the bottom now.
So it's upside down from the way
it's upside down from where it started, clear over here on the end when you started drawing the cup. It's upside down now.
So now you have the ability to hit the bullet from the top with the punch and put dies in the bottom. Oh,
yep.
Okay.
Yep. And then got a boat tail punch. It shoves it through a swedge die, and it'll take it most of the way to the finished profile, but not quite.
Okay.
If you're going on a stony point measurement, you might be 20,000, 30,000 short or longer on the stony point than what you would be on the final swedge. But you're just forming most of the profile, and then we hit it in the edge finish position, which just kind of cleans up that pinch trim edge a little bit.
Okay.
So it's pretty uniform across the end of that. And then we go over to the tip insert position where shove it down in the die, and then we have an ejector that inserts a tip into it and then shoves it up into the fingers. Then it goes over to a final swedge where you're going to hit it the rest of the way to blend the profile with the profile of the tip,
Mm-hmm.
and get it to hang on to the tip good. And you got the stony point measurement you want. And then last position, you're shoving it through a size die.
And that size die on the final, that sets the final diameter.
Final diameter, because you may be, 2/10, 3/10 over our tolerance on bullet diameter, by the time you get to the final swedge.
Okay.
And get through there. And then, we're sizing it down so it's in our tolerance for diameter, which is plus or minus 3/10 on most bullets.
Yep. So if you're making a 308 bullet, it's going to be 308.0, 308.1,
Yeah, it could be 307.7 to 308.3.
Yep. Yeah. That's, and also, I mean, if anybody's in manufacturing, it's probably not so awe-inspiring, but for, just a hayseed in Nebraska, when you see some of the measuring tools that we have, that you're accurately measuring things to the individual tenth of a thou, that's, I don't know, that to me, that's pretty remarkable because we're doing it on such a large scale.
When we're talking jacket concentricity, when we're working on accuracy, we got these little gauges that we can measure the jacket concentricity, and hey, we're seeing 5/10, 6/10, so that's no bueno.
Yeah.
We're not really digging that. We got to get that better, and we'll see it. We'll see it in the accuracy tests.
Sure. Well, that's the next. All right. So Johnny and Mike set up a press, and they go through all the draw processes, and they have this product that pops out, looks just like a bullet. Holy cow! Dimensionally measures everything that it's supposed to measure. Well, that's cool. It looks like a bullet, but now it's got to perform.
Yeah,
so
right.
what's the next step as far as bullet manufacturing goes? You went through all the tooling and the dies and the press. Now it's got to go downstairs.
That's right. Now it goes downstairs, and they're going to load them up, and they're going to shoot them. Match bullets have to shoot 2 10-shot groups at 200 yards. So it's a fairly tough test.
Yeah.
Most of those are around, 850. Our A-tip bullets, we expect them to shoot under 8/10.
8/10 of an inch at 200 yards on consecutive 10-shot
They
groups.
They routinely do that. I mean, I think the other day on those 6.5s, didn't you have just a knot that was just,
Yeah.
Oh, 153s just ran. The 153 A-tip was.
Yeah, they're still on the press
still
right there.
on.
Okay.
Yeah.
And they just shoot
we had
bullets.
what is that? What's going on M3 right now? Is it
That's at 375.
that 375? You should have seen the
The
group that
390?
shot the other day.
You should have seen that thing.
Was 10 shots is just a bug hole.
390
That was
diameter.
unreal, man.
Yeah.
So you question if the bullets are actually making it to
Yeah,
the
it looks
target.
like a 45 caliber hole in the paper.
Yeah. What's the
Wow.
best group you ever got, John?
Well, it's probably with 22 cal 40 grain VMAX. I don't know if it was under 1/10 of an inch, but it was close. I don't remember. I wish I had some of them.
You
from
should have
back
cut
in the
that
day.
and put in your notebook.
See, I had some 50 grain SX bullets I made one time. I got a 150 group.
That's remarkable.
Yeah.
Yeah, and that's the kind of accuracy that we're talking about. Those are varmint bullets. Those aren't even match
Yeah.
bullets, and you're getting that kind of accuracy.
Yeah.
That's shooting in 100 yards. 200's a little tougher. I mean,
Yeah.
you're a little further out there.
Yeah.
I mean, there's times if you got a little bit of a flyer, it's going to show up
Yep.
a little more there where.
Everything's just got to be spot on.
Yeah. And I love that. And I love to see, that now we do this all digitally. And so every once in a while, I'll go into the folder where all those tests are automatically saved for the day. And I'll just go through I shoot the 110 A-tip and they're running right now. How'd they shoot? And I just, look at the accuracy. But let's play a hypothetical here. So you send the bullet down and it doesn't group to our standards. What do you guys do? What's the process there? Because for a layman looking at it, okay, I've got, let's say 14 punches and 14 dies, but the bullet dimensionally measures good. Everything's looking right. It weighs good. Where do you know what knob to turn and how far do you turn it? How does that process work?
Well, where you're gonna start if the press has been running is you're gonna start by qualifying the tooling in the press. And I think John and we're always gonna start by pulling our draw punches. I can learn a lot from what's going on in that machine just by looking at my draw punches.
Okay, how they're wearing.
If they're wearing hard or if they're loading up, if the dies are loaded up, I know that I need to go back and make some adjustments there.
Okay.
But you're going to go back and you're going to make sure your core seat punch fits like it should. And these are rudimentary basics that you would begin with, to make sure that all your ducks are in a row. And on the average bullet, I think if you go through there and you qualify your tooling and you send them down and the concentricity is good, on a standard rifle bullet, you have a pretty good chance of them shooting. I look at shooting percentages every day because it's important to me.
Right.
How many times we're testing. We've got a lot of bullet presses, and if they're shooting 65 tests in a day, it's been a pretty frantic day down in the lab. Our goal is to have them shoot 40 or 45 would be a good number for them, and to shoot somewhere in the 40% range.
Okay.
So lately, I mean, we had a day last week we shot 63%. We had a day last week we shot 52%. Yesterday we shot 47%.
Yeah, but
So-
that's still a far cry from I know there's been times where it's been in the 30% range, and for a variety of reasons. This is going back a few years ago when I helped out down there on occasion, and like I'd mentioned, I know I said it before, but I think right now is the prime time to make accurate bullets.
Yeah, that's one of the things that we push hard is the fundamentals. Look, these are the things you absolutely have to have in order. Now, when it comes to match bullets, and John can speak more to this because that's what he does. He's like their dude.
He's the whisperer.
He is. When they don't know what to do, we go get Johnny, or I'll send him over. I'm sending over the cavalry here, but everything has to be in order. I mean, even on a standard 30 caliber bullet, you want your concentricity to be 2 or 3/10. You want everything to be, as the bullet comes out of that pinch trim die, it's got to grow incrementally as it goes out. So your core seat die has to be bigger than your pinch trim die. Your pre-swedge die has to be bigger than your core seat die, and then your final swedge has to be bigger than your pre-swedge die. And you don't want it to grow in big bunches either. So you want it to just grow a couple of tenths in each position, to have what would be ideal.
Right. Well, and the jackets are, I'm assuming, a work hardenable material. So like you said, if you work them too hard, they're not going to agree with that. And like John said, yeah, every bullet, every cup has a personality, and you have to learn. And that's remarkable. It's like, it's not just anybody can just make it happen. And I've explained this to people before when they're talking about bullet manufacturing. It's like, the guys making the bullets, that is as much of a science and art than it is manufacturing, because you can't just take these punches and these dies, put them in this press and hit the go buttons.
No.
It is very refined. You have to massage certain things, and
For us, the job is not to run the press. The job is to make the press run.
oh wow.
They sound similar, but they're miles apart.
Mm-hmm.
Yeah.
And I think it's one of the things that's so frustrating is you hire young guys and they're clever and they
Mechanically inclined.
generally if they've worked at another job, somebody showed them for 2 or 3 weeks how to do it, and they're as good as the guy that taught them. Here, they could be 2 or 3 years into the curve of learning how to make bullets.
Yep.
And still going, I don't know if I've scratched the surface here, and there's so much to know, and I think it's one of the things that makes John and I we just remember. I don't know why, I don't know if I remember my kids' birthdays, but I can remember, what happened 35 years ago on this one bullet and why it did what it did.
Yep.
And it's
Just
just
lock that away.
It's crazy.
Yep. That is cool. One thing I forgot about, so in that draw process, what we're known for, one of the things that really makes our hunting bullets perform so well is the interlock ring.
Yep.
And that interlock ring, again, critically important that it's uniform, because that could affect its concentricity, but it mechanically locks the bullet jacket to the bullet core. So as it expands, it tries to hold together. So where does that process come into play?
That comes in after the pinch trim position, but before the core insert.
Okay, so before the core comes in, and the
Yep.
punch goes in, and
We got a pinch trim jacket. Now we go in and put that interlock ring in there.
okay, and that's just a punch that squeezes the material?
Well, there's on the final draw punch, there's a feature down towards the bottom of the punch, and they got it strategically placed.
Mhm.
Like if it's a bowtail bullet, it's going to be up above the bowtail a little bit. But on the final draw punch, you'll have a diameter, let's just say it's 200 thousandths diameter if you're running, say, a 6 millimeter,
Mhm.
whatever it is. But 200 thousandths diameter, but the diameter below that, for whatever length it is to get it up above where the bowtail is, it's going to be, I don't know if it's 4 or 5 thousandths on a side.
Yep. Okay, so an 8 thou total.
Or now you got a step. You got a step in that jacket wall there. And then you're coming down with the punch at just slips inside, traps air on the diameter above, but then hits against that thicker part of the wall down below and pushes that material down. You end up with a nice sharp ledge there. And we have a gauge pin test that you have to pass where we have a gauge pin out there. This has to be a certain diameter or smaller, actually, so you know you got enough interlock. And if your gauge pin will slip in past that, okay, you don't have enough interlock. You got to
hit it a little harder.
Got to hit it a little bit harder.
And then you seat the lead core into that, and that's where that gouge, for lack of a better term,
yeah, and
happens.
the core will go in past that ledge. And then when you seat it in there, okay, it fills in every little nook and cranny, but that interlock's now a mechanical lock on that lead between the lead and the jacket where, okay, it would have to slide up past that, for hundreds of thousands before it could get clear of that interlock and then separate.
And we generally we'll cut a core seated jacket in half so that we can see how our interlock is working.
Yep, put that under
the core is completely filled out in the bottom. Otherwise, it may crush when you start to swedge it.
Yeah. And that interlock ring, I know I mentioned it before, but critical part of why our hunting bullets are successful, and it's not just a marketing thing. I mean, that is a real thing that is in a bullet. It does work. I've seen it work. And in my previous job here at Hornady, I shot a ton of our critical duty pistol bullets. Now, I know we've been talking rifle bullets, but we have the FBI contract for 9mm, and we make that 135 gain critical duty bullet. We test that bullet like nobody's business.
Yeah,
and in doing that testing, physically doing it, I saw how that interlock ring worked with the other features on the bullet to make it the single best scoring bullet the FBI's ever tested in 9mm. And that little feature, we're talking 8 thousandths total. Yeah. It's such a critical part of holding a bullet together when you're working with a lead core. I'd like your guys' opinion on how we make bullets. In the industry, there's a lot of lead core bullet manufacturers, and some of them will make bullet jackets, and then they'll take the jackets and they'll make them of a certain size and they'll put them in their storage racking. And then when they get a shop order to make this bullet, it requires this jacket. They'll go get the jacket, put it back into a press to finish the process. And there's a lot of people that do that successfully and make good bullets. But again, nobody can hang with our volume of bullets, and I think our bullets are some of the most accurate bullets ever made in the world. We do ours in a single process. How do you feel about that compared to the competitors out there?
Well, I think they have no recourse. Once they start to swedge those up, there's nothing they can do to go back and change the jacket. We test, we put it together, we get it exactly the way we want. We send them downstairs to make sure that it confirms, hey, not just that we're making a bullet to print, but we're making an accurate bullet. And we test, and like in our A-tip bullets, we're only going to run 50,000 bullets, and we're going to test again, and to make sure that they're spot on. But we have recourse. If they don't shoot, we can go back and change the jacket. We can go back and change different things in order to accommodate what we need to have for our accuracy spec.
So way less scrap, you'd say, because if you ended up with a bunch of jackets that you didn't catch that they were out of concentricity or something, now what do you do with those jackets?
Yeah.
And we would catch it early.
And when he's talking about changing something, we're talking about, hey, we got to polish this die or polish this punch or do something that, okay, we're getting some 5/10, maybe some 6/10 concentricity on this jacket once in a while. Hey, let's see if we can't, get that back down to 2/10, 3/10 anyway. Then we'll have a better chance at meeting the accuracy standard, and then we'll go take care of whatever it is, whether it's removing a draw die, polishing it, or all of them, or the punches. But it's not some sweeping wholesale change where, okay, we're ripping all this tooling out and we're going to put new stuff in.
Yeah, it's massaging stuff.
It's massaging stuff. The punches will get a little, Kenny Doms used to call it the gray sickness on the dies, or, the punches will get it too where, okay, you got a stripper wearing on a draw punch a little bit, kind of scuffed up one side. We'll polish that off, give it a more smooth machine finish like it was when it came from the grinder. And, a lot of times that's all it'll take to tighten up that concentricity a little bit.
Yeah, so
get it back where you want it.
Another reason, just making bullets from start to finish on one single track in a perfectly straight line just works for us, and less material scrap, less process handling, making a more efficient process.
And it really doesn't matter what bullet you make. You have to be meticulous about what you do. It's what makes Johnny really good. That's why he's a good 1,000-yard match shooter, because he's meticulous, because he weighs everything. And he does all the things you're supposed to do in order to be consistent. And if to make the best bullets, you have to have consistency.
You do.
It has to. If you're going to drive them into the same hole, everything coming across that machine has to stay static.
Perfect. That's a good way to put it. And yeah, you have to be exacting, and you have to be passionate about what you're doing. And that's one thing I think you guys could speak to, especially you in the management side of the things, Mike, that a lot of us here are here because we're passionate end users. And that's something I think is an intangible that translates to a better product all the way around, and not just bullets. I mean company-wide. I really do. I think between the research and development teams, the engineering teams, a lot of the operators, there's so many people that do this because they want to, not because they have to.
Right.
Yeah. And I think that translates to a better product.
Yeah. There's always been, on press row, there's always been a lot of pride in what we do. And I think that's important. You know, when you get a really good group, you want to show people.
Oh yeah.
You know, when you
when that happens, there's people there waving around their sheet. Hey, look at this.
Yeah.
Well, there's I think that's kind of a masculine trait, maybe not. I don't know, but where there's pride,
toxic masculinity.
No, I mean this genuinely that when you build something, there's a source of pride in that because I did that and it wasn't by accident, and I did this on I spent a lot of time and effort and energy making this happen, and when you get the fruits of your labor it's rewarding.
It is.
Yeah, and you can go from say you're struggling trying to meet an accuracy standard, and they haven't shot in several days, and you're pulling your hair out, and
then Johnny comes over.
Well, no, I'm talking myself even. You get frustrated. You get, man, you don't know what to do. You think, okay, just calm down. Let's take a step back here. Okay,
detach,
what have I done? What have I not done? Okay, I've touched this, and this, and this. What haven't I touched? Well, what have I not touched that it might respond to? And then you go after that. I mean, you can go from being frustrated as hell because you're not getting this, and I just can't see why this won't shoot.
Mm-hmm.
I mean, I have this. It's a big puzzle. There's hundreds of pieces to this puzzle to make this bullet shoot good.
Yeah.
Hundreds of things.
And you're missing one tiny little piece.
What is it? What is that one thing that this thing needs? I got a good jacket. I'm course seating. The bow tail length's right. It's like, dang it, what have I not touched? And then when you touch that one thing and it responds to it, you get a good test. It's like, okay.
Now I'm back.
It's going in the book.
Yeah. You got to document that one.
Right. That's right.
But it can go from being frustrating to being, you just won the Super Bowl.
Yeah.
The Hornady Auto Charge Pro, providing precise, customizable powder dispensing in an easy-to-use, space-saving unit. The new modernized load cell is precise to within 0.1 grain. The Auto Charge Pro offers customizable trickle speeds for various powder types, as well as custom trickle time settings. With a smaller footprint than competing brands, the Auto Charge Pro still offers a large powder capacity hopper. The Auto Charge Pro from Hornady.
That's pretty amazing. Well, on behalf of everybody who's ever shot Hornady bullets, thank you guys for being part of, what makes the company. A lot of people know us for ammo and our reloading tools, but bullets, they make the company. As Jason Hornady would say, the bullets make the H. Talking about our logo, they're the two pillars of the letter H. They're bullets in there because that's what makes the company. That's what keeps the lights on, for lack of a better term.
We feel like we've spent our last 40 years pretty damn well.
Yeah.
Doing something that we love and working with people. I think that's probably one of the most rewarding things is when you see other people succeed.
Yeah.
It really fills you up because they're getting it, and somebody taught us how to do it. So we have a responsibility to teach other people how to do it.
Mm-hmm.
And I think that's one of the most rewarding things because there's a lot of folks out there and these kids, these young guys, they need some help. They need some direction. They need some encouragement.
Mm-hmm.
you know. And I think it's one thing John brings is he's very patient. He comes over and then he, don't worry, man, we're gonna get these.
Yeah, we're gonna get this.
Don't worry.
He's never not got it before.
No,
That's right.
we always do. We always win.
Got a good track record.
We always win, don't we?
Yeah, we always win. Sometimes it takes longer than others, but
Well, that's a good point, Mike. That it fills your cup to see other individuals succeed in this manufacturing environment, and when individuals are succeeding and thriving, the company's doing better as well.
Yep.
Yeah, it's a win for everybody all the way around, and the consumer is getting a better product. It's kind of all the way around, just great stuff. So before we close this up, guys, I'd like to ask you, one, if you got any closing thoughts on your career and just making bullets in general, and I'd like you guys, if you can think back, is there a bullet that you just enjoyed when you were just normal, press row operations? Is there a bullet when the shop order came in? Oh, thank gosh, we're making 30 cal 150s because I know they're going to run like a skinned cat and I won't have to fight it. Is there a bullet for you guys that stands out?
I made the very first tip bullets we've ever made. The 40 grain, 50 grain, 55 grain, 22 cal VMAX.
Mm-hmm.
And I always used to love to run the 40 grain VMAX because I knew I could get them things to shoot a knot hole at will.
Yeah, that's confidence inspiring.
You could get to run the press and just run beautiful. It'd run beautiful all day long. All day long. You'd have minimal problems. If you cut good lead, you had good cups, you had good tips, man, we're going to make an assload of bullets.
That's a good feeling to have. I like that. And that's we talked about the VMAX bullet here. This has been several weeks ago now. That was released as a new product in 1996 and really set the world on fire and is now the premier Predator and varmint bullet out there is the Hornady VMAX, and that's cool that you had a hand in that one.
Yeah.
He's had a lot in a lot of these things.
Yeah.
A lot of this stuff. I think for me, probably one of my favorite bullets to make was I used to make a lot of 22 match bullets, 2268 grain bowtail hollow point.
Mm-hmm.
That's a great shooting little bullet.
Yeah.
As far as other bullets, just like 338s are just inherently accurate for some reason. Those bullets just always shoot. They're pretty forgiving. 270s are pretty forgiving. They're a good cartridge there. It's a good caliber a bullet to make.
Yeah.
270 130s, we sell tons and tons.
Oh
of
my
those
gosh,
things.
yeah.
But that's a great bullet. We've made a lot of those, and it's they shoot really well and they run well. So yeah,
that's what we like to hear.
Yeah, we used to write down our counts so that that was another.
Oh,
that was another. You not only got them to shoot, but man, I can make my stuff run.
I got little notebooks. We used to, record keeping was a lot different 40 years ago than what it is now. But we used to just at the press at our trimmer bench, we'd have a little booklet. We write down our daily production so we knew where we were at on this particular order.
Yeah.
And I still have books from 1983, 1984, 1985.
Mm-hmm.
And when these younger guys are complaining, these things just don't run very good. 20,000, that's a pretty good day. And I go, that's a terrible day. It's like, you got to do better than that. Come on, let me show you. Let me show you what an old man could do.
Yeah.
Like, I was young when we did this, but I'd bring out the book and people just cringe because they've seen it before.
Yeah.
They've seen it before, but I show them my book. Say, I was making 36,000 a day in a 10-hour day back in 1984.
Mm-hmm.
Yep.
Don't tell me it won't run good. What do you got for problems? Let's fix this.
Yeah.
Come on.
If you didn't make 36,000, you didn't even tell me.
Yeah. You're kind of embarrassed.
Well, and the machines have changed since then too. Even in the decade I've been here, the amount of sensors, the sensors on sensors that sense the sensors.
Yeah.
I would like to know how many miles of wiring go into these things, and the circuitry and the hydraulics is just incredible.
Well, that'd probably be a rebuild department question.
Yeah, that would be.
The electronics we have on those presses now, it's way more advanced. It's like the space shuttle versus a bow and arrow.
The technology from when we started to where we're at today is just way off the charts because even the Waterburys, they're dialed in. Every block is dialed in within a tenth or two. We dial the track in. We make sure the ram's tight. Back in the old days, you just shim blocks around, that was standard. You didn't ask anybody to dial a block in. If you did, they'd tell you just get the hell out of the tour room. That's not what we do here.
Yeah.
And now that's standard. If we have a bullet that doesn't shoot for 3 or 4 days, we'll pull the track and swing the dies and see where we're at.
Wow. Yeah. Times have changed, but the products have remained the same. We're making bullets, some of the best bullets ever made in the world, and between the classic 150 grain 30 cal Spire Point that started the company in 1949.
Make tons of them.
Yeah, we still do, all the way up to the 250 grain A-tip match bullet, which is one of the coolest bullets ever made.
Yeah.
We kind of make it all, and we owe a lot of gratitude, like I said, to guys like you, keeping these presses running, keeping people trained, helping people out, Johnny getting presses running, and I just can't thank you guys enough. You've been great teachers for everybody here, and hopefully 40 more years of making bullets. Well, probably not, huh? You gotta
I don't know if I got 40 years left in me.
Hopefully in 20 years they'll say, remember them two guys? They taught us a lot of stuff.
Yeah, right.
That would be our legacy, is that the guys that are coming behind us, and we've got some really good young guys that are sharp. So we feel when we do retire, when we're done, we'll be in good shape.
Handed it off to good people.
Absolutely.
Yeah. Good stuff.
Let's keep this thing rolling.
Let's do it. Right on.
Let's do it.
Is there anything else you want to leave the listeners with in regard to anything Hornady?
Anything Hornady. I would say there's no better place I could have landed for a career in Grand Island, Nebraska. There is no better place. Hornady Manufacturing's where I was destined to be.
Mm-hmm. And they take care of us.
And I'm glad I spent the last 40 years there.
That's awesome. Yeah, they do take great care of us.
They do. Yep. My ship came in 1984, and I tell you what, I've been so glad that I landed on this one. I've been given opportunities to run a bullet plant. There's nothing really in my pedigree that would suggest that I should be doing that.
Mm-hmm.
Never been to college or anything. But obviously Steve had seen more in me than I saw in myself and gave me that opportunity. And thankfully, I think I rose to the occasion, and not to be the boss, but just to be a partner with the guys out on the floor.
Mm-hmm.
That's kind of how I look at that. Is I'm not the boss. I'm not El Jefe. I am one of.
Yeah. Well, and you started there.
Yes.
You know what it takes.
Yes. And but I'm one of the guys.
Mm-hmm.
I don't. Sometimes you got to be the boss, but I just as soon be one of the dudes and try to make things happen.
With us getting to be the advanced stage that we are, I mean, we're just one piece of the puzzle.
Yeah. Takes a village.
It takes a village. We're one piece of the puzzle, and we're maybe a little more insignificant than we used to be at one time. But
I don't know. Everybody knows you've got a press that's not running. John's coming over.
That's
and
right.
Make it work.
That's what I tell them.
Well, sometimes we got to be a cheerleader too. I mean, people are down in the dumps because things aren't going right. They're struggling, and hey, come on, let's cheer up. We'll get this fixed. Let's go. We can fix this.
Yeah,
it's gonna be okay.
It's like in Pulp Fiction. Johnny's the fixer. What was the guy's name?
I don't know what his name was.
I can't remember.
Awesome. I can remember Samuel L. Jackson.
Yeah, I think everybody remembers that.
That's great.
Well, before this devolves, guys, thanks for coming on the show. Thanks for sharing this and walking through bullets with us. I really appreciate it.
Thanks for having us, Seth.
Yes,
thank you.
You're welcome, guys.
It's an honor.
Hopefully you enjoyed this podcast, this technical deep dive on how bullets are made, and we've got great guys like John and Mike in the company. We've got several others out there that do a lot to help our bullet production. We've got great operators up and coming as well. We're going to make the best bullets that we've ever made, and we're going to make a bunch of them. Thanks for listening. We hope you enjoyed it. We'll catch you on the next one.